Another form that quadratic functions are written in is called standard form, and this is the generic formula for standard form, f of x equals ax squared plus bx plus c. Now this one is a little bit different, and this one is actually used more often than the vertex form. First, we want to identify what a, b, and c are. So a will always be the number that's in front of x squared, b will be what's in front of x, and c is your constant term that has no x. So if we look at this example, we can see that a is equal to 1 because there's a 1 in front of the x squared, b is equal to -6, and c is equal to 8. Now, unlike vertex form, you can't just look at the equation and know what the vertex is. Unfortunately, we're going to have to do math to find the vertex. So in order to find the vertex, we first have to find the x value, and then we will find the y value. So to find the x value of the vertex, x is equal to this formula, negative b over 2a. So we're going to have to use this formula. So we have negative, the b value in this case is -6, and the a value is 1. So we end up getting that x is equal to negative, which makes it a +6. 2 times 1 is going to give us 2. So we end up with 3. So the x value of the vertex is 3. In order to find the y value, we're going to plug 3 in for x in the function. So y is going to be 3 squared minus 6 times 3 plus 8. So we'll do 3 squared, which is 9, minus 18 plus 8. And that's going to give us -9 plus 8, which is -1. So our vertex is 3, -1. Okay, so just like before, we're going to plug this into this chart here right in the middle, 3, -1. So the rest of this problem is pretty similar to what we did with vertex form. The only difference is actually finding the vertex. So I'm going to pick 2 points on each side of the vertex. So I'm going to pick 2 and 1 and 4 and 5. Again, it's symmetric, this parabola, so I just have to plug in 2 of them on this, like 2 and 1, let's say, and then it will be symmetric, so the y's should be the same for 4 and 5. So if I plug in, we'll just plug in 2. If I plug in 2, I'm going to plug it in for x, so we'll get 2 squared minus 6 times 2 plus 8. So 2 squared is 4, minus 6 times 2, which is 12, plus 8. 4 minus 12 is -8, plus 8 is going to give us 0. So 2, 0 is going to be that point. That also means that 4 will have a y value of 0, since both 2 and 4 are one space away from 3, which is the vertex. If we plug in 1 for the x's, we're going to get 3 for the y, so 5 is also going to have a y value of 3. So we'll go ahead and we'll plot this. Here we go. And here we go, right there. So again, we can see, oops, oh my goodness, my graphing skills are not very good. We can see that the parabola points up. The a value is positive from the equation, so we know that if it's positive, it's going to be a smiley face, so we'll open up. The y-intercept, very similar to what we did in vertex form. You can plug in 0 for the x and solve. The standard form is going to be a little bit easier than vertex, because if you plug in 0 for x, everything with an x will be 0. Everything without an x, which is going to be your constant term, that will be your y-intercept. So without having to actually plug in 0 and find the value, I know that if I plug in 0, these will go away, and I will be left with my constant of 8. So the y-intercept is 0, 8. And then the rest is the same as before. Axis of symmetry, x equals the x value of the vertex, so x equals 3. We can see that this opens up, so that means that we're going to have a minimum. And the minimum value is the y value of the vertex, so the minimum value is -1. And then the domain is the same for every single quadratic, so -∞, ∞. And then the range, we're going from the lowest y, in this case it's -1, so bracket -1. The highest y is going to be infinity, and that's our range. So we're going to look at one more example. Okay, first identify a, b, and c. So a is -1, b is 9, C is negative 15. To find the vertex, we'll use the formula x equals negative b over 2a. B is 9, so we have negative 9 over 2 times negative 1. So negative 9 over negative 2, and that's going to give us 9 over 2, which is 4.5. So for graphing, it's going to be easier to graph a decimal rather than having a fraction. I think on a graph we can find 4.5 a lot easier than we can find 9 halves. So 4.5, I'm actually just going to put that there. That's our x value of the vertex. To find the y, we're going to plug in 4.5 in for all of the x's. And if we do that, we will get a y value of 5.25. So our vertex will be 4.5, comma 5.25. So in the y for the vertex, I'll put 5.25. Okay, and just like before, we're going to pick values to the left and to the right. So I'm going to pick 3 and 2, and I'm going to pick 6 and 7. Now we could have picked 4 and 5 as being right next to it, but because the graph at the vertex is 4.5, to go from 4.5 to 4 is very small, so on the graph it might be a little smushed, so I'm just picking something a little bit farther away. So that's why I picked 3 and 6, but they're the same distance away from 4.5. So again, if I plug in 3 for my x's, that's going to end up giving me 3. Because it's symmetric, it will also be 3 for 6. If I plug in 2 for x, that will give me negative 1. Same thing goes for if I plug in 7 because it's symmetric. So I can go ahead and plot these points. And our parabola, as we can see here, is going to be pointing down. The a value is negative, so that makes sense that it would be pointing down. Right? Negative means frowny face. Ooh, bad graph again. So the y-intercept, plug in 0 for x. It's just going to be our constant term, so negative 15. Axis of symmetry, we're going to have x equals the x value of the vertex, so 4.5. The graph is opening down, so that means that we're going to have a maximum, and we'll have a maximum value at the y value of the vertex, so 5.25. And then our domain is going to be negative infinity to infinity. Our range is going to go from the lowest y, which is going to be negative infinity, to the highest y, which is going to be 5.25, and then we have that bracket. Okay, so now we're just going to look at a couple of applications. So we're going to work with applications a lot more later on. This is just kind of like an intro to this. So Alan throws a stone off a bridge into the river below. The stone's height in meters above the water x seconds after he threw it is modeled by this function here. Now notice this function is in vertex form. What is the height of the stone before it is launched? So if we want to find the height before the stone is thrown, that means that the time, which is x, has to be 0. Right? Before it's thrown, it's 0 seconds. So they want us to find the height when x is 0. So we're just going to plug in h of 0, and that's basically just finding the y-intercept. So we're going to plug in 0 for x. And if we do this, we're going to get negative 2 times negative 3 squared plus 34. Negative 3 squared is going to give us 9. 9 times negative 2 will give us negative 18 plus 34 is 16. Because this is a word problem, we want to make sure that we label it with the proper units. So this is the height, and the height is meters, so 16 meters. Okay, question 2 here. A certain company's main source of income is selling bracelets. The company's annual profit in thousands of dollars as a function of the price of a bracelet X in dollars is modeled by this function. Okay, this is in standard form. What bracelet price should the company sell the bracelets at in order to earn the maximum profit? The key word here is maximum. Right? They want to have the maximum profit. So that means we have to find the vertex. Now in terms of the vertex, there's the x and the y values. Now x, they're telling us, is the price of the bracelet. Okay, Y is going to be the actual profit. So they're asking us for the price of the bracelet, not the profit. So we only have to find the X. If they wanted us to find the maximum profit, we would plug the X in and also find the Y. So to find the X, because it's standard form, we're going to be doing negative B over 2A. Well, B is going to be 16, so negative 16 over 2 times A, and A is negative 2. So we get negative 16 over negative 4, which is equal to 4. So that means that we have to sell the bracelets for $4 per bracelet in order to maximize the profit. Okay, again, if they asked us what is the maximum profit, we would plug 4 into this equation and solve for Y. Okay, last question. Kate has 200 meters of fencing to build a rectangular garden. The garden's area in square meters as a function of the garden's width, x in meters, is modeled by this function. Again, this is in standard form. What would the total area be if Kate designed the width of the garden to be 15 meters? So if the width is 15 meters, it's saying that the garden's width is x. So what's the area when the width is 15? So we're going to find A of 15 and just plug in 15 for x. And if I plug in 15 for x, that's going to give us 1,275. Again, this is a word problem, so let's look to see what units we need. And it says here that the area is in square meters, so we'll say meters squared.